Hey guys, so I'm in Physics 2211 here at Georgia Tech, and we recently had a test, and so on one of the problems I struggled with a lot. I looked it over after I got my test back, and going back through it, I realized it wasn't too difficult. I just made some mistakes, and I wanted to go over it, how to do the problem correctly with you guys, in case anyone had any questions or concerns. So, the problem's split into two parts. I got the first part written on the board right here. I'm going to read it to you. So, electrons are fired at the Starship Enterprise by a Romulan spaceship. Data calculates that the velocity of the electrons to be 0.8 c, 0.5 c, and 0, where c is the speed of light. What is the magnitude of the momentum for one of those electrons? So it's asking for the magnitude of momentum. That's what we need to know. So first, let's take what we know. So we know the vector form of momentum to be mass times velocity times gamma. In this case, we have to use gamma because it's a particle. So let's go ahead and, so that's what we need to get going, because in this case you need to get the vector form in order to go to the magnitude. So let's focus on this right side right here first, and then we'll come to this side. So we know that mass is 9 e to the negative 31, because that's given on a constant sheet, but that's just given to us on one of our formula sheets. Next we need to take the velocity, and so what I did is I took the velocity that's given here, and it's given with the speed of light, not taken into account. I went ahead and put the speed of light in. The speed of light is 3 e to the 8th. So I simply took these numbers and then multiplied them all by 3 e to the 8th. And that gave me this velocity vector right here. And it's 2.4 e to the 8th, comma 1.5 e to the 8th, comma 0. And all the numbers I'll be reading to you when they're in vector form will be read in x, y, z component respectively. We'll come back to the magnitude of velocity in a second because we don't need to know that yet. But then we come to this thing called gamma. So what is the formula for gamma? Well, we got it written right here. Gamma equals, I'm sorry, I made a mistake, I was looking for the mark. This should be magnitude. So gamma equals 1 over the square root of 1 minus the magnitude of velocity over the speed of light squared. So we have that formula. So what do we need? We have the speed of light, and we need to know the magnitude of velocity. So that's simple enough. The magnitude formula is right here as well, but I can explain it to you. So you take this, when you're writing out the magnitude of something, you simply just take this x component and you square it, then you add it to the y component and you square it, you add it to the z component and you square it, and you take the root of all that. And when we do that for velocity, we get 2.83 e to the 8th. Right? So now we have this value, the magnitude of velocity, and we plug it into our gamma formula, and what do we get for gamma? We get 3.015. So these three are the important values that we need for the vector form of momentum. Now, when we multiply all that out, we get this vector form of momentum. And across the board it says 6.512 e to the negative 22, comma, 4.07 e to the negative 22, comma, 0. But this question asks for the magnitude of momentum. So what you do is you simply do the magnitude formula all over again. And you take this value, you square it, this value, you square it, this value, you square it, you add it all together, you take the root, and then we get the magnitude of momentum, which we can see is 7.65 e to the negative 22 kilograms times meters per second. I wrote all this out already because I know that YouTube often is constrained for a 10-minute time limit, so I wanted to make sure we get through as much as we can without wasting time already. But I'm going to move on to the next part now, and yeah. Alright, hey guys, so now we're going to look at part B of the problem. So the problem says that Captain Picard wants to reverse the electrons back to the Romulan spaceship. He orders Worf to fire a force field for 2 seconds that reflects the electrons back along their original path. If the magnitude of the electron's momentum is unchanged, calculate the force vector of the force field applied by Worf. So, what we can do in this problem is, let's go to start with the momentum principle, because that's a principle and it's important and we need to have it down and we know how to use it in different ways. So, we know that the momentum principle, a form of it, is delta P equals F net delta T. Now, let's break that down a little more, because in the previous problem, we were able to find how to go about solving momentum, right, in the individual components, right, just P, not delta P, just P, not the change. So, when we break it down a little more, we get to PF minus PI, which is final minus initial, i.e. the change, equals F net delta T. Now, in this problem, we can look back and it says the magnitude of the electron's momentum is unchanged, which is exactly what we calculated in the first part of the problem. So since we know that this is also going to be pi. And we know it's minus pi because it's reflected. So it's the same value, it's just reversed. So when we do this, we get minus 2 of the initial momentum equals F net delta t. And so that's the setup of the formula. But now, what are we solving for? We're solving for F net. So let's go ahead and rearrange this formula. So we got F net equals negative 2 times the initial momentum times delta t, divided by delta t. Now, just to recalculate it, we go F net equals negative 2. We know momentum is equal to gamma times mass times velocity. And in this case, since it's initial momentum, it's initial velocity. One more thing we need to take into account is that we have a 2 on both sides here, so we can go and just do a little crossing out, do a little simplifying right there. And then, when we plug in gamma, which we knew from the previous problem is 3.015, and we plug in mass, which we know is 9 e to the negative 31, and we plug in the initial velocity, which is the velocity from part A, we know that it's 2.4 e to the 8th, comma 1.5 e to the 8th, comma 0. Important to note that this is in vector form. And then we multiply all that out, and since this was in vector form, our final answer will be in vector form, and our final F net vector equals negative 6.48 e to the negative 22, comma, negative 4.065 e to the negative 22, comma, 0. And that's our final answer. So I hope this video helped you guys out. I know at times it can get confusing with all these letters and numbers and things, but if you just follow through each step, I'm sure you'll be able to solve it, just like I did. Have a good one, guys.